Hi everybody. Today we're going to talk about special right triangles, known as trapezoids and kites. The first one we're going to discuss is a trapezoid. As you probably know, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Those parallel sides are known as the bases. They are the sides that are parallel. The sides not parallel are known as the legs. When those non-parallel sides, the legs, are congruent, we call this an isosceles trapezoid. Looks kind of like an isosceles triangle with the top cut off. If we have an isosceles triangle, then we know that the base angles are congruent. Both pairs. We have a top and bottom pair of base angles that are congruent. If the base angles are congruent, then we know it's an isosceles trapezoid. And we also know it's an isosceles trapezoid if the diagonals are congruent. A mid-segment is a segment that connects the midpoints of the trapezoid's legs. Mid-segments are parallel to both bases, and their length is half the sum of the lengths of the other two bases. So let's look at some examples. Example number 1, this is a trapezoid. MN is a mid-segment, meaning M cuts this line in half, N cuts this line in half. I can take the two base lengths, add them together, cut it in half, and I will see that MN is 20. Over here I don't know MN, but MN plus 27 divided by 2 would be 23. So I can set up an equation of x plus 27 divided by 2 equals 23. If I multiply by 2 on both sides, then I go ahead and subtract 27, I will get x equaling 19, meaning that MN equals 19. Looking at isosceles triangle ABCD, I know it, not triangle, trapezoid, sorry. I know it's isosceles because AB and CD, the legs, are congruent. I know that there's a pair of base angles down here that are congruent and a pair of base angles up here that are congruent. So angle A and angle D are congruent and angle B and angle C are congruent. I also know that A and B are supplementary. So if I take, to find angle B, 180 degrees, subtract the 57, I get 123 degrees. Once I know angle C, I know that angle B, I know angle C is the same, and I know angle D is the same as angle A. Our second special quadrilateral is a kite. A kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. The diagonals in a kite are perpendicular, and exactly one pair of opposite angles are congruent. The pair that is congruent is the pair that is between the sides of different lengths. So if you look at kite DEF, angle D and F are the congruent angles because D is between these two different sides and F is between these two sides that are of different lengths. So to find measure of angle D, this is a quadrilateral. Quadrilaterals' interior angles add up to 360 degrees. I know I have 124 and 80 degrees. I add them together to see what the total degrees I already know is. I subtract that from 360, and I can see that D and F together have to be 156 degrees. Since I know that they're equal, I can cut it in half, and therefore I know the measure of angle D is 78 degrees. When I look at kite RSTV, and I want to find the measure of V. Well, I know R is 90 degrees and I know S is 80 degrees. Angle R is between the two different length sides. Angle T is also between the two different length sides, so angle R and T are the same. So if angle R is 90, angle T is 90. So 80 plus 90 plus 90 gives me 260 of the degrees that I already know. Again, it's a quadrilateral, so it's 360 degrees of interior angles. I can subtract them, and I can see that the measure of angle V is 100 degrees. The bottom of this page is a flowchart that breaks down all the quadrilaterals we've discussed in this unit. Take a look at it, process it, and be ready to do some practice problems in class.